Hello everyone, my name is Ajay. So in this video I'm going to explain you about queue data structure. So I'll be showing you the implementation of the queue data structure using linked list. So there are a couple of different ways where you can implement, but in this video I'm going to show you about how you can implement using linked list. So here if you can see I'm having 1, 2, 3. So let's see how we can actually insert those numbers into a queue. So first I will insert 1 and next I will insert 2 and next I will insert 3. So this is a queue in a linked list. Uh, so the next item of 1 is 2 and the next item of 2 is 3, and so I want to use 2 pointers, first and last. So here if you can see the first item we inserted is 1, so I'm naming it as first, and the last item we inserted is 3, so I'm naming it as 3. So queue, we actually follow an approach called FIFO, which is nothing but first in first out. So in queue, if you want to remove an element from a queue, then you have to remove the element which is inserted first. So here if you can see in this scenario, the element which is inserted first is 1. So if you want to remove an element, that would be 1 in this scenario. And for adding any element in the queue, you can use the last pointer for adding an element, and if you want to remove an element, you can use the first pointer. So let's see how we can actually implement it. So queue basically will be having 4 functions. One is enqueue. Enqueue is for inserting an element into a queue. The other one is dequeue. Dequeue is for removing an element from the queue. IsEmpty. IsEmpty is to check whether the queue is empty or not. Peek. Peek will actually return the element which is at first pointer. So these 4 are the functions that I'll be implementing and show you. So these 4 are the basic functions for a queue, and all 4 functions will be taking time complexity of big O of 1, which is constant time. So if you can see, I already implemented a class called node, so where each node will be having data. So here if you can see I'm having 3 nodes, so for each node I'll be having data and the next node as well. Okay, so and also I'm having a constructor here where I'm passing data and assigning the data to the node class data. So I'm using the constructor so that I can create a new node in the queue class easily. So for that reason I'm using constructor. So let's start the implementation of enqueue. So here I'm having class queue, so I'll implement it here. So for inserting an element, we name it as enqueue. So that would be public void enqueue. So here I'll be passing the data. So I have to for inserting a new item I need data, right? So for that I'm passing in data. So and also I'll be having 2 pointers. So one is node first, so I'll name first as F and last as L. So I'm having 2 pointers, F and L. F is first and L is last. Okay, so if you want to insert any item into the queue, so for the first time, the first and last will be null. So in that scenario, you have to just add the new node to, you have to just assign the new node to first and last. So let's see how it is. So whenever I'm inserting a new item, I just want to create a new node. So for that reason I'm creating a new node of this class. I'll name it as n is equal to new node, and I'll pass this data so that I'll get a new node. So once I get a new node, so for the first time in a queue, the first and last pointers will be null. Okay, so for the first time I have to assign first and last pointer to the new node. So let's see how we can do it. If f equal to null, that means the queue is empty. So for the first time I'm just assigning f equal to n and last equal to n. So in this condition I'm just assigning first and last pointers to the node n. This condition occurs when the queue is empty. Okay, so if the queue is not empty and if you want to insert the element, then it comes to else block. So here if you can see in this scenario, I'm already having elements in the queue 1, 2, 3. So if I want to add a new element, let's see how we can add it. So for suppose if I want to add an element 4, so if I want to add element 4, so I'll be creating a new node. So I'll be creating a new node by passing 4 data, and it's not null, f is not null, so it comes to the else block. So here if you can see, for adding a new node in a queue, we can simply make the last node dot next to new node. Okay, so here if you can see, currently I'm having the last pointer at this node. So if I make the last node dot next to the new node, then I can join this new node to the queue. So let me do that one. So else, so last is L here, so I'll just make L dot next equal to n, where n is the new node. So once I make last dot next equal to new node, then I have to move the last to the last element of the queue. Why? Because if I want to add elements further, then I'll be adding using the last pointer. So always have to make sure the last pointer is at the last node of the queue. So for me to move this last pointer from this node to this node, I can simply make last equal to L is equal to new node. So that will make the last pointer. So that will move the last pointer to the new node. Okay. So by this way you can add an element to a queue. So if you can see, for the first time we are just making the new node. We are just assigning the new node to the first and last pointers for the first time. And if the queue is already having some elements, and if you want to add a new element like 4 here, you're just making last dot next to the new node, and you are moving the last to the new node. So for that you are assigning new node to the last. So that's about enqueue, and let's see how we can implement dequeue. So I'll have the same pointers first and last. So dequeue will actually return me dequeue function will actually remove the first element, and also it will return the first element. So for that thing I'm using int return type and dequeue. Okay, so for removing an element, as we discussed earlier, we have to use first pointer. So as per queue, we follow FIFO approach. That means you have to remove the element which is inserted first. So if you want to remove this element, you can simply move the first pointer to here. So for moving the first pointer from here to here, you can assign the first pointer to first dot next. So if I assign a value as first dot next to this first, then I will eliminate this element and the first pointer will be here. So that way I can remove element. So let me write this here. So if q is not null, if first is not null, I'm just checking if q is not empty. So if first is not null, then I have to just move the first item to its next item. I have to move the first pointer to its next pointer. So for that I will just do f is equal to f dot next. Okay, also store int data is equal to f dot data, and I will return the data. What I will let me actually erase this. So I will declare a variable called int data, and so I'm checking if f is not equal to null. That means if the queue is not empty, then I'm just making f equal to f dot next, and assigning data is equal to f dot data. Okay, and finally returning the data. Okay, so here if you can see, I'm storing the data in this variable, the first data in this variable, and finally returning the data. So for that reason I'm declaring the data variable. So I'm just changing the pointer of the first to first dot next, so that way I can remove the element which is inserted first. So this is the function for dequeue, and let's see how we can implement the function isEmpty. So isEmpty will return bool. So this function is actually responsible for checking whether the queue is empty or not. So we can simply write if condition if f equal to null, that means the queue is empty, so we'll return true, else we'll return false. So this is a simple implementation for isEmpty method, and let's see how we can implement peek. So peek is nothing but we have to return the first element. So that would be int, the return type would be int, function name would be peek, and so it will simply return first dot data. Okay, so where f is first, so it will just return first dot data. So that's our peek function. So that's it, friends. This is about the implementation of queue data structure using linked list. So if you have any questions, you can post them in the comment section, and don't worry, you can find all the code. You can get all the code of this implementation from the description of this video. So I'll keep a link of the code in the description of this video, so that way you can get all the code from that link. That'll be all. If you have any questions, please post them in the comment section. Thank you.